Hello, everyone. Welcome to Year 12 Introduction to A-Level Maths and Further Maths. If you have a flair for numbers and are very good at it, can think analytically, logically, then this course is for you. People who have studied maths, further maths, have an excellent choice of careers, many of which involve very well paid profession. Maths and further maths are two of the Russell Group universities facilitating subject, so called because choosing them at A level allow a wide range of opportunities for degrees studying. Now, these are the different careers that you can do if you study A level maths and further maths. You have engineering, business and finance, sciences, IT and computing, armed force, teaching, and there are other job opportunities for you also. Why study A level maths? A level maths is an easy course, which is why it makes you out as a desirable employee or candidate for university. Again, it's also an employment factor. The challenge is wonderful if you like a challenge, and the door is open in terms of careers. Why choose further maths? Further challenge. Employment, enjoyment for maths, most respected A level, and I repeat that it's the most respected A level, most applied maths, and possible a fourth option. Again, it's very good for studying maths, is make you employable. A level maths student and graduate are high demand by employers. Maths is an essential transferable component across majority, a lot of subjects, including science, engineering, technology, and of course, math subject. Currently, 70% of employers state that they're having difficulty recruiting people with mathematical skills. And that's why A level is very good, again, if you're good at it. And it makes you, as I said before, employable. And it's very rewarding at the end because it's one of the highly paid. When you have maths, you get a very highly paid job. At A level in math is key to a high paid. Maths A level make you richer according to studies done. Sixth formers who take further maths A level earn an average of £25,500 by the age of 24. Now, putting a price on the exam, as you can see from this chart, that studying maths and further maths, an average salary over the 6 years is what you see on here. So again, it's one of the most rewarding subjects to study. Why study maths again? If you look at all the different subjects and the different additional lifetime earning, again, maths is one of the highly paid job. It required, if you have A-level maths, if you wish to study maths, statistics, physics, computer science, engineering, or accountancy at university. Again, look at all different subjects as well that you would want to pursue if you want to pursue these subjects. Again, A-level maths and further maths would be an asset. What degree and other qualification do I need to study maths? And this, from this slide, you can tell that maths A-level is a must for degrees in physics, engineering, and all the different subject area. Maths is recommended and sometimes required for computer science as well. Some subject like medicine require two out of this common gang of four subjects, which are maths, physics, chemistry, and biology. As again, very important, maths is. What could I study? If you do A-level maths, you could do one of the following: pure maths, applied maths, financial maths. Again, you could do maths, physics, mathematical biology, operational research, and computing. Now, before you consider doing A-level, it's a must that you have at least a grade 7 in GCSE. And if you plan to do further maths in A-level, you must have a grade 8. Now, A-level versus GCSE, the style of question and analytical thinking and self-revision is required a lot. The difference between the old spec and the new spec is that with the new specification, you do that exam at the end of year 13 and not like before, but the grades are still the same, A to E. This is the course, the outline of the course, 33.33%. And it gives you on each paper what is required. And then, of course, you have maths, pure maths, that is, statistic, mechanic. Further maths is here. These are recommended resources that you could use to help in reading a bit more on further maths and A-level maths. Now we're going to be looking at, just to give you a quick synopsis of A-level lesson, one which is on A-level, pure maths, that is, and one is on mechanics. Now we'll first start with the binomial expansion A-level lesson.
Okay, so here's a starter for you. Just see if you can have a go at these, remembering maybe your indice laws from GCSE, and see if you can see a pattern. And then what do you notice about when we show the answers in the back? Well, when I show you the answers, anything about the coefficients and the powers of A and B. Okay. So pause it if you want to go through and give them the answers. I'll go through and give it a go. I'll show the answers now. So A plus B to the power of 0. Of course, anything to the power of 0 is 1. Here's the answer for A plus B to the power of 1, power of 2, 3, and 4. So the coefficients, numbers in front, is there anything you notice with them? Okay, because there is a pattern forming with them. So if you said they're all follow Pascal's triangle, you'll be correct. Okay, so you've got 1 at the top, the 0th row, 1 and 1, which is the first row, 1, 2, 1, which is the second row, 1, 3, 3, 1, third row, as you go on. And then if you look at the powers individually, specifically the powers of A and powers of B, as the power of A, it decreases as you go from left to right. So A to the power of 4, to the power of 3, to the power of 2, to the power of 1. And then power of B increases as you go from left to right. So that's how that what is worked out there. Okay, so here's Pascal's triangle if you can't remember, just a bit of a recap. Remember this top row, this 1 by itself, is the 0th row. We start, or we say this 1 and 1 is the first row. Okay, so you add the two numbers to make the numbers below, and it carries on and carries on. Okay, so as you can see from the pattern there. Quick fire question. See if you can remember it, pause it. See if you can remember it, write it down. Here's the answer. 1, 2, 1. Remember, it's the third row of the triangle overall, but we call it the second row because that top one doesn't count. Pause it, give it a go. Okay. 1, 4, 6, 4, 1. Again, fourth row. Pause it, see if you can remember it. 1, 3, 3, 1. And finally, 1, 5, 10. 10, 5, 1. Notice that they are palindromics. They're the same forwards as they are backwards. Okay, and then it's just a recap, just to remind you of Pascal's triangle. Again, stating, making sure that this 1 by itself is the 0th row, not the first one. So let's have a look at the question. Here's a bit of a hint. See if we can solve this question. Okay, I'll pause it, or if you want to pause, if you want to give it a go, pause, but I'll explain and I'll talk us through it. Okay, so the reason why we've got this bar here, the blue bar, is because we're looking at the row in Pascal's triangle. What tells us that is that row? Well, if you look at the power in this, it is power of 4. So we're going to look at the 4th row. Okay, so that's the first step. So look to the power, see what row you're using, go through there. And as we can see, 1, 4, 4. 1, 4, 6, 4, 1. Sorry. Next one. Remember what we have to do with the terms and then the coefficient, sorry, the powers, which is step 2. So if you're writing it out, you've got the x as the first term. And remember, these powers decrease in size. So if you have x to the power of 4, then it will go x to the power of 3, x to the power of 2, x to the power of 1, and then finally x to the power of 0. Next step, look at the second term, so that 2y. Okay, you do the opposite. Okay, 2y starts at 2y to the power of 0 and then increases. So it goes 2y to the power of 0, 2y to the power of 1, to the power of 2, etc. as it goes through. Okay, and then add the coefficients according to Pascal's triangle, which is what we've got there, the 1, 4, 6, 4, 1. You should have an answer that looks like that. Okay, so we've highlighted where you get the steps from. So in red are the numbers from the Pascal triangle. So the 1, 4, 6, 4, 1 is your fourth row of the Pascal's triangle. The numbers in, or the terms in green, are your coefficients increasing. So your first term decreases. So if you look at the x to the power of 4, that's your first term, it's decreasing. So you've got x to the power of 4, then it's x to the power of 3, x to the power of 2, x to the power of 1, and that should be in green, but x to the power of 0 there. Okay. Then look at your second term, which is the 2y. It starts off as 2y to the power of 0 and it increases as it says in step 3. So 2y to the power of 0, power of 1, power of 2, 3, and 4. Okay. And then the next part is tidying it up. So we've got all the terms there. Okay. And don't forget that anything to the power of 0 is 1. So if we're looking at this first part, so 1, x to the power of 4, 2y to the power of 0, it tidies up to just x to the power of 4. Because 2y to the power of 0 is 1. So therefore 1x to the power of 4 times 1 is still x to the power of 4. Okay, just remember that. And the same over here in this last term, x to the power of 0 there would give us 1. So 1 times 1 times 2, 2y to the power of 4. Okay, so give it a go. Pause the video, give these ones a go, and then we'll move on. Okay. So you should have given it a go, and here's the answer to this one. Okay, again, color coded just to show where you get the answers from. Okay, so we're looking to the power of 3 here. So it is the third row on the Pascal's triangle, not that top one. Third row, because the top one is the 0th row, if you want to say that. And we go 1, 3, 3, 1, as it says down here in the Pascal's triangle. Okay, the first term, 2x to the power of 3, because that's your original power, say in the brackets here, and then it decreases in size. Again, that should be green. I don't know why it says 2x to the power of 2, 2x to the power of 1, 2x to the power of 0. Your second term, minus 5, starts off as minus 5 to the power of 0, minus 5 to the power of 1 as that increases, and you should end up with minus 5 to the power of 3. Tidying it up, and there's your answer there. Oh, sorry. How we get the answers, we just need to make sure we can work through. So let's, if we pick 3 brackets 2x to the power of 2 minus 5 to the power of 1, we've got to solve it. So easiest thing to do, minus 5 to the power of 1 minus 5. Okay, we can solve that. And then we've got here 3 times 2 to 2x to the power of 2, so 2 squared. 2x squared is 4x. And then we times it by 3, which gives us the 6. Okay. And then that gives us the answer, and that helps us here. So don't forget to tidy up your answers there and then simplify it with the following. So follow through on everything, you simplify and get the right answer. Okay. Here's this one here. Okay, so the coefficient of x squared is in the expansion of 2x minus cx to the power of 3 is 294. So again, do the same method. Okay, what row in Pascal's triangle? Well, you row 3 because it's power of 3. 1, 3, 3, 1, that's where you get the red numbers. Okay, your first term is the 2, your second term is the minus cx. Okay, here it specifically asked for this, the second term, because you're looking at to the x squared. So find that one where it says x squared. So if we look, it's this term here, so plus 3, 2 to the power of 1, brackets minus cx squared, and then you work through that one. Okay, so let's say it's got it underneath here. 6 brackets cx squared is the same as 6c squared, x squared equals 294. Okay, so we just get don't need the the x squared at the moment, because it asks for the coefficient of x squared. Okay, so we've worked it out here as x squared is c squared equals 294. So divide by 6 and then square root it to find your answer of positive or negative 7. Okay, so take your time, have a look, see where you got the answer or the answers from, make sure you're correct. And then here's a few questions to go through. Pause it, give yourself time to go through it, and the answers will be explained at the end of the video. Thank you very much. Moving on. Can't pause it. Just have to go. I feel like if I stop the recording, it's going to stop the whole thing. Yeah, I think so.
Are you sure?
I think so, yeah. So obviously we've got the recording. So can you... Okay, here we go.
Hi, welcome back. We're gonna have a taster in mechanics, and we're just gonna look at a simple topic in A-level, resolving forces. Before you would attempt resolving forces, probably you would have done a bit of work on vectors, a bit of work on forces in physics as well. So what we're going to do today is that we're going to be splitting force into two components. So we are going to split them into the X direction and then the Y direction. Right. So here is a force lying diagonally, 10 newtons. So what we're going to do here is we're going to go along here, and then we go up there. Okay, so what this means is that if we add along, which is X, and then up Y, we should get the hypotenuse, which is 10. So X plus Y should give us a 10. So what we're going to do is we need to find a component for the X direction and then the Y direction. So what we're going to do is quickly have a quick recap on what we've done in GCSE, trigonometry. So, right. Okay. So what we did in GCSE, we looked at how to label these parts. All right. So first of all, we're looking at the X direction. It means we don't want this one just yet. And the X direction is adjacent to the angle. So we have the adjacent and we have the hypotenuse. So we're looking at something that is got the adjacent and the hypotenuse. So we don't need this one, we don't need this one, go that one. So cos, ka means is adjacent over hypotenuse. So all we need to do is that we're gonna do cos 35 is equals to adjacent over the hypotenuse, which gives us X over 10. All right, so we need X. We want to find X. So we make X the subject of this formula, okay? Or we cross multiply if you want, whichever way you call it. Okay, so we're going to find that X is going to be 10 cos 35. That's it. That's for the X direction. Now we need to look at the Y direction. So in order not to get confused, let's cross off the X this time. We want the Y direction. Okay, So y says, so we're going to go back to ka, and to y. Okay, now this time around, we've got the angle which is opposite to y. We haven't got any information on x, we're looking for y. So we've got y and the hypotenuse, which is 10. Remember Pythagoras theorem. If you add this to that, you get that. If you add x to y, you get 10. Okay, so what are we looking for? We want opposite and hypotenuse. Opposite and hypotenuse, that gives us. So we're going to go the same way. We have sine 35 is equals to, it's opposite over hypotenuse. So opposite is y, hypotenuse is 10. Then we cross multiply with y subject. So y is equals to 10 sine 35. Nice and easy, straightforward. So that's just the basis, the intro. Right, these things keep repeating themselves. So when you have the opposite, you go with sine, and then when you have the adjacent, you go with cos. We'll be looking at tangent later if we're looking for the angle. That's an angle. Slide. All right, we'll look at another example. Okay. Right, so here's another, no, next one. PowerPoint. Okay, here's another example. So you want to have a go at this one, just follow the same example. So we're finding the component of the force in the x direction and the y direction. Okay, so going up here. Let's go back to this one, right over it. Okay, it's going up by across. So that leaves us with our rectangle triangle nicely. So the x along this time is the opposite, and then the y is the adjacent. Okay, so we're looking at the component in the x direction. Okay, so x, the angle is directly opposite. So we still go Okay, so what we're looking for is the hypotenuse, which is the same as the force, which is diagonally 5 newtons. So we've got the hypotenuse, we've got the opposite. So I said to you that if we have opposite, we're going to use sine because we've got the information here, opposite, and then hypotenuse, opposite, hypotenuse. So what we're looking for is that sine 20 degrees, 20 is equals to, the opposite is x, and then is 5. Okay, so we're looking for x, it's going to be x equals 5, it's going to be sine 20. Same way, I'm looking for y, which is up there. We don't want the x. So the y is the adjacent. So adjacent is going to be cos. So you're going to do cos 20 is equals to adjacent over hypotenuse, and adjacent is the y. Hypotenuse is the 5. Let's multiply. Y is equals to 5 cos 20. That's your answer. Very simple. Okay, now this time around, we are right. This one is going to be proper reverse. Okay, so we still go split the force into two components, along, which is the down, which is the y, and then the x. So x and y. Okay, so here we we're going to have some negative, but we're not going to be concerning ourselves with the negative just yet. We just want to make sure we've got the components correct. Okay, so if we want to look at x first, x is opposite to the angle. So when it is opposite, we use sine. So the same way as we did the first one and the second one, we're going to do sine 25 is going to be, so let's put our slope and 2 up. Okay, so sine 25 is going to be, it's opposite, so it's going to be sine opposite over hypotenuse, just like that. Okay, so the opposite is, so our hypotenuse here is 6, don't forget. The same as the hypotenuse. So we're going to do x over the hypotenuse, which is 6. So we want x, and that's going to give us x is equals to 6 sine 25. Okay, y this time is the adjacent. Don't want the x. If it's adjacent, it is adjacent over hypotenuse. So the same way we're going to do cos 25 is equals to, look at y over hypotenuse, which is 6. And that leaves us as y is equals to 6 now. 6 cos 25, right? If you look at this one, or if you want to concern yourself with the negatives, you can see that the y is going down. So you can put it as y is equals to minus 6 cos 25, but we're not bothered about that just yet. When we come in, we need to take care of that. Okay, so here are 3 examples for you. You've looked at the examples. I've got some questions for you to try. If you want to pause the video, have a go at them. And once you've finished, we can. Yeah, so try these ones there. Okay, so just using the same format that we used. Have a go at them, and then you can check the answers later.